So we have this question which has this graph outlined here. You've got points labeled A to E. You're told that B and D are stationary points. And your job is for each point A, B, C, D, and E to work out if fx and f dash x and f double dash x are either positive, 0, or negative. Well, if we look at just the first one, fx, what does fx represent? Just fx.
Yeah, it's just the point itself.
No, well, it's related to the point, but what about the point in particular, to be clear?
The function.
Well, the point has two things, right? What describes a point?
The coordinate.
It has both an x coordinate and a y coordinate, and fx would be which coordinate?
The y.
Right, so this is really talking about the y value, or the y coordinate. So let's just do that first. So A, for A, is it positive or negative, or 0?
Positive. Negative.
C,
Negative 0.
easy, right? So the next thing we need to remember is our first derivative. What does that, what does that mean?
The gradient of fx.
At that point, right?
Yeah.
Good. So basically, if if you're not comfortable with the idea of gradient of a function, then think of it as the gradient of the tangent. And so we can kind of draw the tangents in. Now this diagram's not perfect, but that's your tangent at A, that's your tangent at B, that's your tangent at, well, that's kind of the tangent at C. Probably that's the best approximation there. A, D, and then your E kind of looks like that, roughly. All right. So you know that if it's upward sloping, it's positive. If it's horizontal, it's 0. And if it's downward sloping, it's negative. So looking at the blue lines, which represent the gradient, which represent the tangents, and considering the gradients, what can you tell me about f dash x? Okay.
It's negative.
Yeah.
And then 0. Positive.
Yeah. And remember, you were told that B and D are stationary points. So by definition, this by definition already tells us that f dash x equals 0. We already know that from the definition. All right. What does f double dash x represent?
Second derivative.
It is the second derivative. But graphically, what does it represent?
If the graph is concave down or up.
Right. It's concavity. And so you kind of need to just consider at this point here, is that concave up or concave down section? If it's concave up, it's positive. If it's concave down, it's negative. So is it a concave up or concave down?
Up.
Right. So is it, what can you tell me about A?
Positive.
B.
Positive. 0, negative 0.
C.
0.
Again.
Negative.
Negative. And if you've got an inflection point, then not by definition, but this requires f double dash x equals 0. So remember, I've said before that the second derivative equals 0 doesn't mean you've got an inflection point necessarily, even though it probably usually will be for SL. But having said that, if you do have an inflection point, you can say that the second derivative must equal 0. Okay. Did you have any trouble with this, with the table? Or was it
I was
just
just a bit confused with the first derivative.
Okay.
Because you know how we usually, before we said that if the gradient is positive, then f dash x is bigger than 0.
Yes.
But then, oh, wait, one sec. I think like if the curve itself is kind of increasing, then it's
Yeah.
positive. But
So
then
like B to
isn't
C,
A
for example.
increasing?
No, A is decreasing because it's going down as you go to the right.
That's true.
We're always thinking of as X value gets bigger. So in graphically, that would mean as you go to the right. So no, it's downward sloping. So it's decreasing.
But isn't the gradient increasing?
But the gradient is increasing, but the function isn't. And the gradient is just asking for the value of the gradient. If the gradient is increasing, that's real concavity. And that's why concavity is positive at A.
Oh, okay, yeah.
So basically, f dash x is asking you the value of the gradient, or if the function is increasing, right? F double dash x is asking you for the concavity of the function, or if the gradient is increasing or decreasing. Does that make sense?
Yeah.
Is that all clear?
Mm-hmm.
All right. So you're then asked to describe the turning points of y equals fx. Well, you really would just say, you know, that B is a, or you would really need to say there in this for something with information, with limited information you have, is that B is a minimum and D is a maximum. That's really all they're looking for, really. You could mention that if you want, B is a local minimum and a local maximum. You know, with, and I don't think anything else is all that important. B is a local minimum with a, you know, value less than 0. D is a local maximum with a value greater than 0. And if you're trying to then describe your inflection point, then, you know, you wouldn't have too much to say here other than that C is an inflection point, you know, with an X value that's positive, X and Y value that's positive, and it's an increasing inflection point. There's not, you know, you don't really have much to say here.
Yeah. Okay.
Great. Any questions with that?